This is the video for lesson 7.4 where we are going to be discussing special right triangles. And there are two types of special right triangles. Those are the 45, 45, 90 triangles, also called right isosceles or isosceles right. And then we're also going to be discussing the 30, 60, 90 triangles, and those are just half of an equilateral triangle. So before we get into the ideas here, let's go ahead and put in our learning target. Make sure you're using a pencil, please. And then we're going to go ahead and fill in our vocabulary. So I can solve for measures in special right triangles is our learning target. The first type of triangle we're going to discuss is going to be the 45, 45, 90 triangle, which is also often called a right isosceles. So the 45, 45, 90 has two legs that are the same length, and then the hypotenuse, and we're going to fill this in here, the hypotenuse, which is the longest side, is going to be the square root of 2 times as long as each leg. So for instance, if a leg is 11, let's just say, then 11 times square root of 2 is the length of the hypotenuse. And we're going to look at a couple of examples here in just a moment. The second type of special right triangle that we're going to be looking at today is the 30, 60, 90 triangle. And in this triangle, the hypotenuse is 2 times as long as the shorter leg. And the longer leg is square root of 3 times as long as the shorter leg. So we need to remember all of these different lengths compared to the sides that they're supposed to be compared to, and this will be posted in the classroom as well. So let's go ahead and take a look at the first example. The first example has to do with the 45, 45, 90 triangle, and if we take a look here, this leg is 11, so therefore this leg is 11 because we have a 90-degree angle here, and these two angles are going to be 45 degrees each. And we know that if the angles here are 45 each, then the sides have to be the same length, and this is an isosceles triangle. So we have to solve for this, which is the hypotenuse. And we learned just a second ago that the hypotenuse is equal to the leg times the square root of 2. So for this problem, we have a really easy solution. X is going to equal 11 times the square root of 2. And that's all we had to do there. Example problem B is going to be a lot more complicated because we have the hypotenuse length, but we do not have the length of the leg. So to begin with, let's think about how we can find the length of the leg. If we know that the hypotenuse is equal to the leg times the square root of 2, we need to be able to find the leg length. So we have to divide this side by square root of 2 to cancel that, and divide this side by square root of 2. So our new equation to find the leg length is going to be leg equals the hypotenuse divided by square root of 2. And if you recall from your work with radicals quite a ways back, there cannot be any radicals in the denominator of a fraction. So we're going to need to do some extra work here. This one is going to take us a little bit of extra time. So we want to solve for the leg, which is x, but we know the hypotenuse is 2 root 6. This is our hypotenuse because it's opposite from the right angle there. Okay, so now we have the hypotenuse and we need to divide by square root of 2. We can't divide this 2 by a square root of 2 because it doesn't have a radical symbol. Okay, so we can only divide things that are underneath the radical. And so it looks like to me the square root of 6 and the square root of 2, both of those are under the square root, so I can divide that square root of 2 into this square root of 6. Okay, so to simplify this one, 2 root 3 is going to be the final answer, and that's the length of each leg in this problem. Next, I'd like you to do the practice problems here. And in problem 1, you're solving for a leg. So you're going to use the formula that we just were looking at from the previous example problem. In this one, we're going to be looking for the hypotenuse. So please use the equation for the hypotenuse. And again, here we're going to be solving for the hypotenuse, so use the hypotenuse one. So you just have to make sure you know what you're solving for so that you know which equation to use. All right, let's take a look at example 2. It says find the height of an equilateral triangle. An equilateral triangle is one that has all sides congruent and it has all angles congruent. And if you recall, those angle measures are 60 degrees. So this angle up here is 60, this angle over here is 60, and so is this one. And what we're being asked to do is to find the height of the triangle. So the height would be from this vertex straight down. Okay, if I have a 90-degree angle there, and I've split this angle up here into 2 equal parts, now I actually have 2 of these. I have a 90 here, right, because of the height coming down. I have a 60-degree angle here because this angle was 60, and I have a 30-degree angle up here. So now I have a 30, 60, 90 triangle. This is a 30, 60, 90 triangle. And I know what the lengths of the sides are. It tells me right here that the length of the sides was 6 root 3. And that was the fact for all of those sides on that equilateral triangle. So what is just the length of the short side? What's that length right there? If the entire length was 6 root 3 originally, well, we can just divide that by 2. Half of 6 root 3 is going to be 3 root 3, right? 2 goes into 6 3 times. So now I know that this side is 3 root 3, that's the short leg, and we're still looking for h, the height of the original triangle, which was equilateral. So how do I find that longer leg? Well, here's a formula right here that when we want to solve for the longer leg, that's the height, we're going to take the short leg, which in our case is 3 root 3, and we're going to multiply that by the square root of 3. So I'm going to multiply the things that are underneath the radical, this times this. So now my equation looks like this, 3 root 9, because 3 times 3 under the radical is 9. But then I can say, well, the square root of 9 is 3, so now I need to multiply 3 times 3. So the height of the triangle is 9. So some important things to remember. A 30, 60, 90 triangle has some specific ways to find those lengths. They are listed at the top of your page, and here's one more to add to that. And equilateral triangles, when they're split into 2 equal halves, form 30, 60, 90 triangles. And we're going to try some example practice problems on the back. All right, one more example problem before you get to practice some of these on your own. This one is also involving the 30, 60, 90 triangle, and looks like you're going to be solving for the short leg as well as the hypotenuse. So hypotenuse is always the side opposite from the right angle. This one I'm going to abbreviate with SL for short leg. So to find the short leg, we are going to take the long leg and divide by the square root of 3. And to find the hypotenuse, we're just going to take the short leg and multiply by 2. So we actually need to solve for the short leg before we can find the hypotenuse. That's going to be easiest for us anyways. And so let's go ahead and get started. So I want to take the 4 root 3, which is the long leg, and divide by square root of 3. And that's going to simplify real nicely because basically the square roots of 3 cancel. So the short leg is going to be 4. And to find our hypotenuse, we're just going to take 4, which we just found out for our short leg, multiply by 2, so the hypotenuse is going to be 8. Okay, so the key, of course, to solving these problems is knowing which side you're solving for and which formula to use to be able to solve correctly. Okay, there are 5 remaining practice problems, and I would like to set the first 2 up for you, and then I'm going to give you some hints about the last 3. So let's go ahead and look at number 4. An equilateral triangle has side lengths of 24. What is the height of the triangle? So if you remember, example number 2 was just like this problem, except it had a different side length. So let's go ahead and draw an equilateral triangle. Each side length is 24. And you're going to be solving for the height, which is the long leg. Remember, this is a 60-degree angle, this is a 60-degree angle, this was a 60-degree angle until we cut it in half, and now it's a 30-degree angle, and we have 90-degree angles down here. Okay, so really, if I redraw this, you can see that we have 90, 60, 30, and the length of this side here is 24, and the length of this side here is 12, because of course if you cut that side in half you get 12. So we're looking for this long side. Okay, and so how do you find the long side? You take the short side, the short leg, and multiply it by square root of 3. So that should give you a hint at how to solve for the height. And for number 5, the equilateral triangle has a height of 13 root 3. What are the side lengths of the triangle? So let's go ahead and draw this out. We have an equilateral triangle. We have the height, which I'm going to draw in green. And that height, of course, is 13 root 3, which is what they gave us. And they're asking for the side lengths of the triangle. So we need to know, what is this side length? What is this side length? What is this side length? And so there's a couple ways we could do it. I think that just looking for the length of the hypotenuse is going to be the easiest. But you can also find the short leg, and the short leg is going to be the long leg divided by 3. So let's go ahead and do that. Now what I mean by the short leg is this length right here, half of one of the sides. Okay, so I'm going to label that SL for short leg. And if I'm looking for one of the sides, then I can just double that, right, to find the whole length, because the short leg times 2 is the length of the hypotenuse as well. So I hope that helps you find the length of the side based on the drawing that we did and the hints that I gave you for that. So I'm next going to look at numbers 6, 7, and 8. Okay, numbers 6, 7, and 8, each one of these is a 30, 60, 90 triangle. So I want you to go back to your formulas that you've gotten and make sure you identify which side of the triangle you're looking for. In this case, this is the long leg. And in number 7 and in number 8, it looks like you're solving for the hypotenuse. So be careful, use the correct formula. And I'm going to give you an answer bank down here. The answer bank for these is 10, 21, and 62. So your answers for numbers 6, 7, and 8 should come out to one of those answers there. And I will be checking for completed work and giving a stamp for those that are done. Thanks for watching.